Hello and welcome to part 7 of Rust for Beginners series. This video will be about generics and traits. So generics are placeholders that we can use instead of using concrete types, and they help us write less and clean code. Let's write some code to better understand where we can use generics. So let us suppose we have two vectors, one integer and the other one character, and we want to find out the largest element in both these vectors. So the normal approach will be to write two functions, one to find the largest element within the integer vector and one for the char vector. But if we take a look at the logic of both these functions, it is basically identical. The only difference is the parameter data type and the return type. So in this example, we can create a function that takes a generic type so that a single function can find the largest irrespective of the type of data. So first let's remove one of the function and then rename the other one to the largest. Now after the name of the function, we'll put a t, which will signify that this is a generic function. We can use any letter here, but generally we use t or u. Now after that we can replace the type within the parameters and return type. Let's fix the name of the function within our print line. Now there is still one error which is within this comparison, and this is because the type of data is not known yet, so it's not sure whether it can apply this operator or not. So in this case we can use a trait which will ensure that this operation is valid. Now we'll talk more about traits in a minute, but for now let's just use the partial order trait, which allows operations like greater than, less than, greater than equal to, or less than equal to. So we'll simply put a colon after t and then define our trait, which in this case is partial order. We can give as many traits as we want, and if I also had an equal to or not equal to operator, then I had to give partial equal trait, which can be done by using the plus operator between traits. So this is an example of a function that uses generics. Next we'll take a look at structure that uses generics. Okay, so we'll start by creating a structure called coordinates, and it will have two parameters, x and y. Now instead of giving concrete types to these parameters, we'll take a generic. Just like functions, we'll put a t after the name of the struct to signify that this is a generic structure, and then we can use it as a type for both our parameters. Now if we create an instance of this structure, it will automatically take the type which is given within the parameters. We can use any letter or any name for this generic type. I can put x1, x2 or anything as a generic placeholder. But as I said earlier, we generally use t and u. Now we can have multiple placeholders and use each of them for giving different types to different parameters. Now when creating methods for these structures, we first have to define the generic after the impl keyword, and again after the name of the structure. Now it's not necessary to match the placeholder variables, but the number of variables should be the same in both the structure and the implementation block for the methods. And then for using them in the methods, it's same as that with functions. Also, it's not necessary to use these generics within the function defined within this block. We can use concrete types here as well. Traits are very similar to interfaces of object-oriented programming languages, although there are some differences. A trait defines the functionality a particular type has and can share with other types. We can use traits to define shared behavior in an abstract way. Now if we take a look at the code which we wrote for the generics, we can see we used a trait here. Now this is called trait bonds, which is used to specify the behavior that a generic type will have. Let's take a look at an example to better understand their use case. Okay, let's suppose we want to group up a bunch of shapes together and define some common behavior among all of them. For that we can define a trait called shape. To create a trait, we simply write trait keyword, name of the trait, and then all the functions with parameters and return type. Now every shape has some common behavior like area, parameter. So let's define a method for area first. Now unlike the methods which we create for structures, here we don't need to give the body of the function. We just need a signature. Now it's not necessary to define the body of the method, but if we want, then we can give a default body. Now our trait is ready, so let's create some structures that implements this trait. Okay, so we have these three structures: square, rectangle and circle. Now to implement that trait, we'll do impl shape, which is the name of our trait for square. Square is a structure. Now once we do that, we can see we have an error, and that's because we need to define body for all those functions that were defined in the trait but didn't have any body. So let's quickly return area and parameter for both these methods respectively. Now even though we have already defined the body for number of sides, we can override that body by creating a new body within this implementation. Next I'll repeat the same thing for rectangle as well as circle. For circle, let's start by parameter and then we'll use this parameter to calculate the area. Now we can use any method defined because of the trait as any other method of the structure. Now both our trait and structures are ready, so now it's time to use them. I'll start off by creating one variable for each of the structure. And then let's suppose we have a question of is the area of the structure same or not. Now to calculate this area, we will create a single function called check area. And instead of giving a concrete type of square, rectangle or circle, we can just use a generic type. Now the first generic type for this check area function is t, which will have a trait called shape. Next we'll add another generic type u, and this will also have the same trait. And then we'll take another variable for this new type. Now the reason I have taken two generic types, even though both of them have same trait, is because both of the structure can be different. For example, if t is square, ru can be rectangle, circle or even a square. But if I don't use u, then both a and b will be of same type. We'll simply compare the area and return the boolean. And our code is basically ready. Now for a and b we are getting false, which is correct. Now let's change the value of rectangle to make it a square and also have the same area as our a variable. And as expected, we are getting true. Now one final thing for trait is that we can also use them as actual types. So let's create a function called print area. In this we'll take a parameter and this will be of type IMPL shape, so implementation of shape. And since we just want to print it, we'll borrow this value instead of taking the ownership. And we are getting the area of our shape. So this was all about generics and traits, and I hope you understood the concept of generics as well as traits, especially traits as it's unique for Rust. So that's all for this video. Please give a thumbs up if you enjoyed this video. Do consider subscribing, and I will see you in the next one.